going to finish up chapter 10 as well as the addendum that I added to it. We may not get to the last couple of slides. I didn't in the first period, so we'll see how it goes. All right, so we're going to be using word problems with all the features of quadratics, focusing on vertex and what it means in context, x-intercepts and what it means in context, putting that away while I do the notes so you can focus on me and in context. X-intercepts, y-intercepts, all those key features that we found yesterday. Okay? Alright, so we got a farmer with 100 feet of fencing. He wants to put a fence around the rectangular field next to the building. Look at this beautiful picture. We want to find the maximum area he can enclose. So first off, maximum refers to what part of a quadratic? What does maximum refer to? Most, but in specific with a quadratic, refers to what part? What key feature? Vertex. So that gives a hint right off the bat. We're looking for the vertex of a quadratic. The same would be true if it was asking for a minimum. Okay, depending on which direction the quadratic opens, we could be looking for a maximum or a minimum value. Okay? So he wants to put a fence around the field next to the building, find the maximum area he can enclose, and the dimension. So we want to find the maximum area. What do I know about areas of rectangles? Length times width. So I know I'm going to be using a formula for length times width. Well, no, I have 100 feet of fencing. The area is not 100. I need to find the maximum area that I can get with 100 feet of fencing. Depending on how I set up the rectangle, I could use 100 feet of fencing very differently and end up with different areas. Okay? So, for example, if I set it up as 1 foot by 100 feet, okay, that'd give me 100 square feet. But if I spread it out, I can end up with more area with the same amount of fencing. Okay? So I have 100 feet of fencing to use. I want to find the maximum area, which means I need to know the vertex. Okay? And find the dimensions, and that'll be part of that process. X represents the sides perpendicular to the building. Okay? So I've got those two sides there. I don't need to fill in this side because that's where the building is. I do need to figure out this side. So I need an expression because I can use X to represent the length, or the width, whatever you want to call it, but I need something else to represent the width. Well, if I just have W and then I can't solve for anything, right? I need something in terms of X. So here's what you need. This is where the 100 feet comes in. I want you to think about it this way. I've got 3 sides. I use X feet over here, and I use X feet over here out of the 100. How could I figure out how much I have left to fence in the long side? Yeah. Take away what I have, subtract the 2 sides that I use, and that gives me what's left over. So now I have, in terms of X, length times width. Length being the short side, width being the long side. 100 feet minus the 2 sides that I already used, that's going to be whatever's left over for the width. Now that I have an equation in terms of X, I can go ahead and solve. So let's write it in quadratic standard form. Negative 2x squared plus 100x, just some distributed property and commutative property. Okay, negative 2x squared plus 100x. So this is my equation that represents the area of that depending on how wide or how long I make each side. So what can I do to find the vertex given this quadratic? We have a couple methods. If I wanted to factor, that would get me to my solutions but not my vertex. What do I need to find the vertex? Yeah, we could just use our vertex formula. You can either use vertex formula or complete the square, depending on which one is going to be easier for the context. So I can use my vertex formula, x equals negative b over 2a. 25. Okay? So x equals 25. So is that the length or the width? 25 square feet. That's my maximum area? That's what x equals. I said x equals my length, right? This right here is 25 feet. Okay? Now, the other part of the vertex. Think about your vertex. I've got 25 as my x value, right? And x value represents this. Okay? Looking at this equation, x being one of my sides, what does my y value represent? Not length. My width. What does my y value represent? The area. Because my equation, my two-variable equation, my output is area. Output. Dependent variable. Y represents area. While my independent variable, my x value, my input, represents x, which is the side of that fence. Okay? So the y value of the vertex is going to give me the area. The x value gives me the width of that side. Now there's a couple different ways I can get to this dimension. What can I do now to get that dimension?
Plug it back in.
Plug it back in where? We could, but I need to know the area. And I want to make a point, because you guys said plug it back in, but I want to note, if I plug it in here.
Yeah, so you can plug that in for area.
Yep.
Divide it all by 25.
Okay, so that'll give me the area. There's another way that I can get my width, though, or the width.
You can add the two x's together and subtract something.
Remember this equation that we said represents width? If I plug it into just that part, then it gives me just my width. 100 minus 2x, 100 minus 2 times 25. So that gives me a width of 50. That's a highlight. Let's do that. A width of 50. So I have a length of 25. I have a width of 50. So I have this area formula that I could use to solve for the area, or I could just take my length times my width. What's my area going to be? What's my area going to be?
Times 25 times 50.
Yep. 1,250 square feet. That's also the y value of my vertex. Length, width, and area. So it's really important that you can identify and understand what each value of your vertex represents in that context.
So the ordered pair is the answer?
No. This is the answer. What I'm saying is the ordered pair gives you the length, gives us one of the sides perpendicular, and it gives us the area, and then we can use a combination of methods to find the missing piece, the 50.
Then what it asks, is all of those, like,
It said, find the maximum area, there we go, and the dimensions of the field. Dimensions of the field. Does that make sense? There are 3 answers that it wanted. And sometimes when the questions, again, they ask for a maximum, they don't want the ordered pair, because we may not need both parts of the ordered pair. We may only need one part of the ordered pair. So it's making sure that you can identify what does each value in the ordered pair represent so that we're giving the correct value. Okay? The x value doesn't give me the area of the field, but it does give me the maximum length that I need, so that I can use that to figure out what the area is going to be. Alright, we got a toy rocket launched from the ground. Distance above the ground after t seconds is modeled by this equation. So what does S of t represent? What does it stand for?
No, speed.
Distance. Distance above the ground after t seconds. So distance above ground. And then t represents time in seconds. Okay? Find the maximum height. That means I need to solve for S of t. And the number of seconds needs to solve for t. So I need both parts of the vertex. Maximum height will be the x or the y value of my vertex.
Maximum height?
Yes.
Why?
It would be the y value. Because distance is my output, right? So height represents y, so the height will be the y value of the vertex. I don't know why I spelled vertex so weirdly. There we go. Okay, so the y value of the vertex will represent the maximum height. The number of seconds by process of elimination, okay, will be the x value.
So if the thing's output done is y.
Yes, output is y. Our dependent variable. Input is x, or independent variable. Okay, not all of our real world models use x and y, but the concept is still the same. The input is the independent variable, equates to x. The output, the dependent variable, equates to y. Alright, so I know maximum I need to find my vertex. How do I find my vertex again? Negative b over 2a. What's my b value? 208. What's my a value?
16.
Negative 16. What does that equal?
That is also
It'll be a decimal.
this 6.5.
Why would the 16 become positive?
Because of the equation, it's negative b over 2a is negative 16. Oh, wait, no, mine.
I mean, I have a negative over a negative, which becomes positive.
No, because six, that's your distance, right? 6.5 is the distance, right?
No, 6.5 is not the distance.
It's negative 208.
I didn't follow the 8. Sorry. Yeah.
See, so we're doing this 2 times things.
I have a negative 208 divided by a negative 32 gives me a positive 6.5. Okay, so 6.5, that solves for x, right? So that gives me the number of seconds. So 6.5 seconds. Now I want to find the height. Now I can plug it back in because the y will give me the distance. So I solve for s of 6.5.
So what do you got?
6.5?
Oh, 5 brackets.
That's s. S of t. S of t. $2,028. Is he right? Make a toy rocket shot up 2,000 feet in the air. Maybe up a little big.
Right.
Why I should have more than one person checking in their calculator. That's fair.
How do you get that? What did you do?
I think that's a little bit more accurate. Can we verify 676?
Yeah.
I'm sure.
I believe that's
Wait,
right.
how?
You could.
You don't use this. This is just saying y equals. The height at time 6.5 equals negative 16 times the square of 6.5 plus the product of 208 and 6.5. Okay? So our height, max height is 676. Did we answer both parts? Yeah. We wanted to know the time. We got 6.5 seconds. We wanted to know the height. We got 676. The vertex would be the x and the y. 6.5 comma 676. That would be the vertex. 2,000 feet. 676 is about right for a toy rocket. 2,000 is, I mean, that's almost a mile. Alright, so now what we're going to do is we're going to expand on some of these key features, and we're going to talk about domain, range, average rate of change, positive, negative intervals, and increasing, decreasing intervals, all in the context of a word problem. So I've got one word problem to start, and we're going to kind of look at all of these different things. We're going to be focusing on x-intercepts, y-intercepts, and vertex. that's going to give us kind of a lot of the values that we use for these different things. So to start, the story is that we've got a pelican spots a fish. So pelican here, and spots it, dives down to catch it, gets it, and then goes back over the surface to enjoy his well-caught meal. So domain, just in general. Domain talks about what part of a function? The x value. So for every quadratic, our domain is what? Excellent. But now in context, we have to ask ourselves, what's a reasonable domain? Okay? Because that pelican, if our domain is talking about x, and x models time, that pelican is not immortal. Has not lived since the beginning of time, and will not continue to live well past us. Okay? So now, and also it's not even the whole pelican's lifespan. We're just looking at this specific scenario. So if we're looking at a reasonable domain with time, what's a good starting point for time? 0. So a reasonable domain is going to start at 0. When does this particular event end? After how many seconds? 4, 2, 9, 1. It starts here and ends there. Okay? Alright. So that's our reasonable domain. Starts and stops. I don't care about anything before or after that time. Okay? So that's going to be the reasonable domain for that specific section. Now, reasonable range. Again, this pelican isn't flying up to outer space. So it's not going to keep going forever. So what's going to be a reasonable range within this context? To 22. Okay? -5 to 22. Here's. What's that? I do. Yeah. Okay, it might be close to that. Okay. Oh, well, you're special. All right. Now, reasonable range, reasonable domain. Okay. So that tells us when stuff is happening and when it's done. Identify the decreasing interval. Decreasing means to do what? Go down. So the decreasing interval is literally asking when, within our domain, does the graph go down? From 0 until when? Until 3. It's going down from here to there. So our decreasing interval is where we have a negative slope. When is it going down? From the domain 0, okay, with a bracket, but note, for 3, it's a parentheses. Well, because at 3, it's flat. It's not going up or down. It's neither.
Why is it not 3?
Because I'm looking at the interval from 0 to 3. I don't care. And then whenever we're talking about intervals, it's always relative to the domain. So the x value where it starts and the x value where it stops. So it starts going down at 0 and it stops going down at 3. Yes?
And you said 0 was the here?
Yes, 0's in a bracket because it's going down there. Okay? Let me make that bracket a little bit more clear. There we go. Okay? Because I can see the slope right here is negative. But right here, the slope is 0. At that one specific point. So we're going up to 3, but not including 3. And then increasing means that we're going up. Okay? So where does it start going up? At 3, again, parentheses, because it's still flat at 3, but right after it, 4.291. And that will be, because the slope is still positive. Okay? So now, during the decreasing interval, I know my graph is going down. What does that mean the bird is doing? I misheard what you said, so I don't want to wait and I'm going to answer your question first. So, the slope is negative on my decreasing interval. So the graph is going down. So in the context, what does that mean the bird is doing? It's going down too. Because my y value represents height. Okay? So the height of the bird is going down. So the bird is flying, and then when it hits here, now it's swimming down. Okay, so it's flying and then swimming down. So that's what the decreasing interval is. So what is the increasing interval? Swimming up. Okay, so again, it's just context. It's just making the connections. Okay, it's not supposed to be overtly difficult or tricky. It's just helping you just understand and make those connections. What increasing interval represents? It's the change in the y. Since the y is talking about height, if the y is going down, then the height is going down. Whatever our y value represents is going up or down, respectively, for increasing and decreasing interval. Now, our next interval is positive and negative. Positive and negative is a little bit different than increasing, decreasing. Increasing means the slope is positive, it's going up. Decreasing means the slope is negative. But positive and negative intervals is talking about when the function is either positive or negative. When the function is positive or negative, meaning our output, the y values. So all of my y values above the x-axis are positive, but all my y values below the x-axis are negative. So that's the difference between increasing interval versus a positive interval. Within the positive interval, I have a decreasing interval and an increasing interval. Within the negative interval, I have a positive or a decreasing and an increasing interval. Okay? So they're talking about two different things. A lot of times it's flip-flop, so try and make that distinction early. It's going to save you a lot of trouble. So what is my positive interval, again, within our relevant domain? Always with the x values. 0.
1.7.
Good. 0 to 1.709. Okay? Here, and then parentheses.
You said to use the
It's when the y values are positive or negative, but intervals are always written in the domain. So from here to here, my y values are positive. That's what it's saying. Okay? What about negative interval?
3 and 4.
I can start before 3.
Oh,
1.709.
is 0 a negative number?
0 is neither negative nor positive.
So it's going to do something.
Yes. So that's why at the 1.7 and the 4.2, we use parentheses, because it's neither negative nor positive. So that specific point is not in the negative or the positive interval. So we use parentheses for those intervals. Because 0 is negative, neither negative nor positive. Okay? So what does the positive interval tell me about the bird? It's above water. Right? So our positive interval here represents above water. What does the negative interval represent?
It's on water.
Not on water, underwater. Our x-axis is on the water. Yes?
What about the second?
Well, remember we said our reasonable domain stops here, and so I'm going to stop there. If I needed to include it, if my scenario did continue on, then we would just have a union. We would have a union that would pick up at 4.291. And then continue off to whatever. That's only if we need to have it. Okay? Which happens. Alright? And then average speed. What's my fancy math word for average speed?
That's velocity.
And velocity. Doesn't velocity also include direction? No, direction.
So velocity with the speed.
I want to know for average anything.
Me?
I mean, let me rephrase it. Average rate of change.
Oh, slope.
Slope. Okay? So its speed, its average speed or its average rate of change is going to be slope. But since it's a parabola, I don't have a constant slope. The slope is changing with every given point. Okay? So I have to find it between two particular points. And so I'm going to focus on the time it started, which was when? When did it start? started here, and when it caught the fish, 3, -5. Okay, so I need the slope of that line. What's my slope formula? Okay, so y2. Okay, and y1 would be, okay, and then x2 and x1. So 27. Good. So my average rate of change is, for that interval, is 9 feet per second. Okay? It's actually not very fast. It's not for a bird. Think of peregrine falcon. What was the SAT question? 150 miles an hour?
Yeah.
For a peregrine falcon? Yeah. So, negative 9 feet per second, or 9 feet per second, which direction? Down. So again, that negative also implies meaning. It means it's flying down. If we found the slope over here, it would be positive, meaning that it's going up. And again, that ties into the increasing and decreasing interval. Decreasing interval means it's going down. All right? Now, all of those questions were based off of those 3 features. We just used those 3 features to answer all of those questions. So when we're given a situation like this that we need to kind of look at the graph, that's what you need to find. Your vertex, your x-intercepts, and your y-intercepts, and see what they refer to. We just need a quick sketch, and then it makes it easier for us to visualize the scenario that's happening. So I have Antoine standing on a balcony throwing a ball to his dog, okay? So here's Antoine standing up here, all right? And he throws a ball down to his dog, all right? There's his dog, okay? So he's throwing a ball down to his dog. So we have a quadratic that kind of models this curve. So let's find these points and plot them and see if we can interpret based on the graph and relate it to our little picture here, all right? Vertex. So negative b over 2a, so negative 4 over 2, okay? So 1, okay? So my vertex starts at 1, well, there's 1, so there's my axis of symmetry, but I need the y value now. Well, going back in, negative 2, 1 squared plus 4 times 1 plus 16.
8 plus 16.
It's not 8 plus 16 because that's a negative 2 plus 4.
Yeah, but then why don't you square?
You square the 1, 18. Okay, so my vertex is at 1, 18. Pay attention to the scale on here because I had to fit it all. There's your vertex. Okay, all right, x-intercepts. A couple ways to find those.
Oh, set each.
So x-intercepts, we set y equal to 0. Okay, so negative 2, x squared minus 2x minus 8, x minus 4, x plus 2. So x-intercepts are going to be 4, 0, and negative 2, 0. So here and here. I just factored it. It's pretty easy to factor it. You could complete the square, and that would give you the vertex pretty easily, and the x-intercepts pretty easily as well. So again, I've given you guys a ton of different tools. Pick whatever works best for the scenarios. If I couldn't factor it, then I'd have to use quadratic formula or complete the square. Depending on the question, would change which one I would do. Y-intercepts. Set x to 0, okay? So solve for the height at time 0. Negative 2, 0 squared, plus 4 times 0, plus 16. equals what?
Where did the 0 come from?
Gotta plug in 0 because it's too much.
The 0 came from y-intercepts are when x equals 0. So we made x 0. Okay, so my y-intercept is going to be at 0, 16. And then we can use symmetry to fill in this point. And now I've got my quadratic. Okay? See how this, oopsies, is disappearing. Let's change that to yellow. That would be way smarter. See how this kind of looks like that. Make sense? So it just models the trajectory. All right? So we're going to use these points to answer the following questions. So kind of keep it handy. I'm going to be going back and forth looking at the graph. All right? We ready? Okay? All right, so first question. How long was the ball in the air? So what part of my graph tells me when the ball was in the air?
Everything that's
Everything above the x-axis. Okay, so my positive interval. So how long the ball was in the air is going to be measured by my positive interval. Okay, now again, reasonable domain in mind. What is my positive interval going to be? When does it start? So he throws the ball at -2 seconds. 0. Reasonable domain. We start at 0. And it ends at 4. Okay, so my positive interval is from 0 to 4. So how much time is that? 4 seconds. 4 seconds. Okay? Now,
I don't understand.
so how long the ball was in the air, he started at 0 seconds, he threw the ball, and it traveled along down until it reached his dog. Okay? Y representing the height, X representing time. So since he started at 0 and the dog caught it at 4, then how long the ball was in the air was that time, 4 seconds. Okay? So we've got our reasonable domain, 0 to 4. The positive interval is a parentheses here. The domain is 0 to 4. Because what the key difference is my x values, right? Domain is all of the x values. Positive interval means that y has to be positive, right? Is y positive right here? It's neither positive nor negative. Can you wait 5 minutes? Okay. So my positive interval is 0 to 4, non-inclusive on the 4, but the domain is from 0 to 4. Huh? You can't wait 5 minutes? Maximum height. What was the maximum height of the ball? 18. What am I looking at to find that? The vertex. Okay. What was the minimum height of the ball? 0. What am I looking at for that? Not the vertex. So the vertex here is giving me the maximum height, and then the x-intercept here is giving me the minimum height. So my maximum height comes from the vertex, specifically which value of the vertex? The y value. So we got the y value of the vertex, that gives us the 18 feet. The minimum height comes from the x-intercept within our domain, the x-intercept, and that gives us the x value of 0 feet. What's our reasonable range? 0 to 18. That's our range. Does it reach 18 feet?
The ball can't go there.
It can't go negative, but it can be 0. The ball can be 0, so it's included. It can be 18, so it's included, and it reaches from there to there. I included the parentheses on the 4 on the positive intervals, specifically because it asks for the positive interval. Okay? Actually, the question didn't even ask for the positive interval. I'm just indicating, hey, the positive interval talks about this part. Okay? The domain is brackets from 0 to 4. The range is brackets 0 to 18. The only reason I got the parentheses here is because it's specifically positive interval, and at 4, I'm at y of 0, and that's not positive, and that's not negative. Okay? So, same question. How long was the ball traveling upward? From 0 to the vertex, which is 1 second. Okay? So again, we're getting that information from the increasing interval. Okay? How long was it traveling upward? That's the increasing interval, and that was 1 second. Okay? The increasing interval was from 0 to 1. 0 to 1. That gave us 1 second of time. Okay? How long was the ball traveling downward? More than that.
No, from 1 to 4.
From 1 to 4, 3 seconds. So 3 seconds with a decreasing interval of 1 to 4. Okay?
Why does 1 have
Because at 1, we're talking about increasing interval, right? So the slope has to be positive. At 1, the slope is 0, which is not positive or negative. Okay? All right, the average speed from when he threw it to when it reached its maximum height. From when he threw it to when it reached its maximum height. What 2 points am I going to look at?
0 to 1. I call it negative 6 for when you threw it.
He didn't throw it over here. He threw it up here. See our picture? He's up in the air, and then he threw it. He didn't throw it from the ground and then over the balcony and then. Okay? So I'm starting at 0, 18, and then I'm going to where? I'm sorry, 0, 16, and then 1, 18. Okay? So my slope will be from 0, 16, and then from 1, 18. Okay? From one point to the other. So y2 minus y1 over x2 minus x1. What's the average rate of change? Positive 2 feet per second. Or meters, whatever the unit is. Okay? 2 meters per second. What is the average speed of the ball from when Antoine threw it to when it landed on the ground? So I'm still starting at 0, 16, but what's the other point that I'm using? 4, 0. Okay? So y2 minus y1 over x2 minus x1. Negative 4 meters per second. And then last one is just going to be that vertex from the maximum height to the ground. So 118 to 40 over 1 minus 4. So that gives us 18 over negative 3, so negative 6 meters per second. Hey, we did it. We got all the way through.